Okay, welcome back, biology students. So in this lecture segment, we're going to talk about the rules of the science game. That is, how it is that scientists go about figuring out how nature works. What process do they have to use to figure that out? And it turns out if you are a professional scientist, there is a particular process you have to follow in order to figure out how nature works and then provide evidence that your idea about how nature works might be the right idea. So let's talk about how scientists figure things out and provide evidence. The first thing you have to do if you want to figure out how nature works, you got to look at nature, right? You got to actually open your eyes and take a look at what's going on around you so that you can see what it is that needs to be explained. Usually, most scientists do not spend their time trying to explain things that other people have already explained, and most people have accepted those explanations. So what they try to do is they try to find something in nature that hasn't been explained yet, or that there's still a lot of controversy about. That is, there's still a lot of argument about the explanations. So I'm going to give you an observation that you might go outside and make that would need explaining from your perspective. Now, it turns out this particular observation has already been explained scientifically, but the average person doesn't know the scientific explanation, and it's actually rather complicated. So it's something that a lot of people do observe just in the course of their lives and sometimes wonder about, but it's a very good question. So keep in mind, though, when we're doing this, that science is about explaining things that haven't been explained about nature, things that are not obvious. Sometimes the explanation for something is very obvious. And science usually doesn't spend a whole lot of time, scientists don't spend a lot of time trying to explain the obvious. Nobody's going to pay you lots of money to explain what's obvious. Scientists look for things that don't have an obvious explanation, and they try to explain that. That's what you make the money for. All right, so here's something you may have observed that does not have an obvious explanation. When you look up at the sky, this is just a picture of the sky, here's the sun. When you look up at the sky on a clear day, the color of the sky, normally the sky will appear blue. If there are no clouds in it, it generally appears blue on a clear day. So the question is very simple. So that's the observation. I observed that, okay, on a clear day, the sky looks blue. Now, right away, that may kind of bring a question to your mind. And if it did, then you're following the scientific rules, because the second part of the science game is to ask a question. So once you've made that observation, okay, on a clear day, the sky looks blue, you're going to ask a question. Science is about answering questions. But before you can answer a question has to be asked. So my question then, I observed that the sky looks blue on a clear day, and my question is very simple. Why does the sky look blue? Why that color? Why doesn't it look green? Or white, like the sun? For example, if you look at the sun here, the sun is white. So, and the sun is what's lighting up the sky, right? So how come if a white ball of fire is lighting up the sky doesn't look white like the sun? So it seems odd that it looks blue. It's white here, but it looks blue over here. That seems odd. So the question is, why? That doesn't have an obvious answer, right? You can't just tell by looking. So why does the sky appear blue on a clear day? Why isn't it white like the sun? Or clear, like the air? And a sort of an ancillary question to that, or corollary to that, is how come the sky doesn't appear blue at night? At night it's transparent, right? You can see right through it. But how come it's not transparent during the day? And why does it take on that funny color? Actually, it's kind of a pretty color, but why? So here we have the beginning of science. As soon as you observe something in nature you can't explain and then ask a question about it, why does that happen? How does that happen? Then you're starting to do science. That's the beginning of science. Science begins with observations and questions, always. And it really, if you think about it, it flows out of the natural human curiosity. We all are naturally curious critters, right? It's the nature of humanity to be curious, to want to know things, to want to explain things. That's our nature. And so science is a focused way of doing that. It's taking part of our nature, that curious part of our nature, and trying to focus it on actually explaining the things that we see. Okay, so in science, you observe, you ask a question, then what? All right, now I've got this question. Why is the sky blue? What do I do next as a scientist? Well, the next thing is you've got to explain. You have to come up with your own explanation. So scientists don't just ask questions, they then come up with explanations. They come up with answers to their questions. So as a scientist, you develop what's called a testable idea or a scientific hypothesis, which is an answer to the question that you asked. And usually scientists try to answer their own questions. Sometimes they'll try to answer somebody else's. But sometimes they'll actually figure out the question themselves. They'll do their own observation, come up with their own question, and then they try to answer it themselves. Other times they'll take somebody else's observation and question and try to answer their question. But your answer, the answer you give, has to be in the form of an explanation, and it has to be what's called a testable explanation. So we'll get into what the word testable means here. The form that you're going to do a scientific hypothesis in is the because form. So when you're answering a question scientifically, you say, that happens because. And whatever is after the because, that's your hypothesis. So in this case, I think the sky is blue because, and now what I write next is going to be my hypothesis, my idea. So for example, one idea, if you ask the average person why the sky looks blue during the day, you'll get a lot of people who say this. It's blue because the Earth's oceans are blue and the sky is actually reflecting the blue color of the oceans. So that's their hypothesis. That's a lot of people's hypothesis for why the sky looks blue. Now, we've got to see if our explanation here, our hypothesis, is actually a valid scientific hypothesis. We have to make sure that it passes a few tests. One test is if it's a valid scientific hypothesis, it can't include anything supernatural or subjective. So you can't use anything purely subjective or supernatural to explain the sky if this is a valid scientific hypothesis. For example, I can't say, I think the sky looks blue because God likes the color blue. Now that actually might be the true answer, but it is not a scientific answer because it invokes God. It invokes the supernatural, and scientific ideas are not allowed, you're not allowed to use the supernatural. That's part of your contract as a scientist. Now, if you think that's overly restrictive, again, I mean, all games, if you think of science as a game, all games have rules, and if you don't play by the rules, you get kicked out of the game. For example, if you're a professional baseball player, you might decide that a fun way to play baseball would be to, after you get a hit, to run to first base and tackle the first baseman so they can't tag you out. Now, so you're kind of combining baseball and football. So that would be a fun game. I think that would be a really fun game. But that is not the game of baseball. And if you keep doing that as a professional baseball player, if you keep trying to tackle the first baseman, you're going to get thrown out of a game and then you're going to get fired. You're going to lose your job. So again, if you're agreeing to play the science game here, if you're a professional scientist and you have to play this game, you are not allowed to use the supernatural in your hypothesis. Now, this hypothesis I came up with here, the sky is blue because it's reflecting the ocean color, that does not use the supernatural. There's no gods or demons or souls or anything there. So far, so good. This so far passes our scientific hypothesis test. Now, the other thing that makes this a scientific idea, it has to be testable. And what that means is that you have to be able to use that idea to make a prediction. And then you see if and you should be able to see if that prediction comes true or not. So that's what we mean by testable. You can use the idea to make a prediction. You can say, if my idea is correct, then if we do this, we should see that. That's a prediction. So if the idea can be used to make a prediction, you can then see if the prediction comes true or not. And if it doesn't, that indicates your idea is wrong. That's what we call the falsifiability. That means that we can show this idea is wrong by showing that the predictions it makes are wrong. So if we can use this idea to do that, then it's a scientific idea. And as we'll see in a minute, you actually can test this idea that way. So it passes the predictive test. So it doesn't use the supernatural. We can use this idea to make certain predictions. So it passes that. Finally, you should know that scientific hypotheses don't have to be correct to be scientific. Just like when you're playing the game of baseball, you don't have to win to be a player, right? Not everybody who plays baseball gets to win. Only some folks get to win. But if you're in the game, you're still playing. So scientists get to play the game, and playing the game sometimes means they're wrong. It means they come up with ideas that turn out to be wrong. That's okay. In science, that's fine. It's okay to come up with an idea that's wrong. It's still scientific, even if it turns out to be wrong later on. In fact, in science, wrong ideas are actually very useful, because the more ideas people propose that we test and turn out to be wrong, that narrows down the possibilities of which answers are right. So if we can exclude a bunch of answers because they're wrong, then we get closer and closer to what the actual answer is. So in science, wrong answers are useful. As it turns out, this particular hypothesis is wrong. Scientifically, it's been demonstrated to be wrong. But a lot of people who aren't familiar with the science of the sky, that would be their first idea. And it's still a scientific idea, even though it isn't correct. Because it doesn't use the supernatural, and it is a testable idea. You can use it to make predictions.